Okay, so there we go. I'm going to get rid of that cubic formula. We don't want to see that. That's awful. Okay, so what are the techniques we have for factoring currently? All of them. There were 3. 10 meet. Okay, so number 1. The first thing you always want to look for is to check to see if there is a common factor. But we don't want to just check for it. We want to check for it and remove it if it's there. The GCF. There might be one, there might not be one. There doesn't have to be one, but if there is one, deal with it. What is the next thing that would be useful to look for? Just because I taught them to you in a particular order doesn't necessarily mean that that is the order in which you should look at things. Because we're going to have to do that regardless. After you've checked for and removed, if possible, the GCF, the next thing you want to look for is that special case I gave you yesterday. You want to check for a difference of squares. Because if there is one, you're done, and it's easy. This step, and it's important to recognize here, this step right here, this may happen multiple times. What does it mean for something to be a difference of squares? You have a, yeah, Carolyn? You have a square, a perfect square, minus a perfect square. So this could include variables. If you have a squared variable, it's obvious. Like x squared is x times x. But the ones that are less obvious are what happens if you have x to the 4. Is that a perfect square? Yeah, because what is x to the 4th? It's x squared times x squared. Is x to the 6 a perfect square? It's what times what? It's x cubed times x cubed. Is x to the 8 a perfect square? So what kind of exponents are you wanting to look at on the variables? Any even exponent on a variable is going to give you a perfect square. Any even exponent on a variable is a perfect square. Which is not something we talked about yesterday. That's something you may have noticed, but now let's put it down there explicitly. If we remove the GCF, we've checked for a difference of squares. If there's not, what is our last option? And again, you might have to check for squares multiple times. If you do it once, you may have to do it again. You may have to do it again. You want to make sure you check each piece. And then the third time, or the very last thing you check is the one that involves the most amount of work. What is our last option? Yeah? Yeah. Now we want to deal with, and in this case, they're all so far for you, what they're going to be is simple quadratic trinomials. And what was the simple quadratic trinomial is something that looks for this: x squared plus bx plus c, where that leading coefficient is, I'm not putting an a there because the leading coefficient on a simple quadratic trinomial is always 1. Thank you, Carolyn. So what is the technique for dealing with these? Yeah, 10 me.
The last number and the numbers, what times to the last number should add to the middle coefficient.
So you want two numbers that multiply to C and add to B. And these need to be the same set. Sometimes you might have more variables in here, like there might be x squared plus bxy plus cy squared. It's the same technique, but the only thing that's going to be different now is once you find those values, either it's going to be x plus or minus something, and then it's going to be x plus or minus something else, or it's going to be x plus or minus something times y, x plus or minus something times y. You're going to have something that looks like that, whatever these two numbers are. These are the techniques that I've shown you thus far. And this is what you want to do. I could be real nasty to you and say something like this. Even after you've dealt with a simple quadratic trinomial, there could be a time where you need to deal with 2 again, depending on how I've set it up. Every time you factor, you always want to end up checking for a difference of squares. There are ways for me to make all sorts of crazy things that involve difference of squares multiple times. I don't think you've seen one yet, but it could happen. We will. There is more to come that we're not doing today. I'm just going to give you a bit of a... Questions about any of this? This just sums up everything we've done over the last 4 days. And this is a set of things for you to follow. I know some of you like to have, okay, what do I do? This, then this, then this, then this, then this. This is a way for you to order your thinking. There's more to come. Something like this. I'll say more to come. ... all ominous. Something like this. ax squared plus bx plus c, where a is not equal to 1. Or perhaps you can't find this, multiplying to c and adding to b. What do you do in these cases? Those are techniques you're going to look at next year. And like I said, the way it's currently looking is like you'll do that with me, assuming you're taking Predip 10. We'll do that next year. So, in the time that remains, for those of you who looked at the homework that I did yesterday, I just want to take up some questions. If you didn't do the homework yesterday, well, pay attention or just kind of launch into whatever it is you're working on here. I gave you the odds from here. Is there anything anyone wants to see? Carolyn, you said number
1.
Number 1. Okay, let's look at number 1. First thing we want to look at is GCF. Okay, is there a greatest common factor in those two terms? Yes. What can I pull out of both terms? X. So let's do it. If I pull out an x here, what do I have left? Divide by x, x plus 2. Next thing I want to check for, bless you, perfect squares. Or just, sorry, difference of squares? No. It's not a difference. Neither of these are perfect squares. And it's not a trinomial. It's done. We're over. It's finished. Sure. Is there anything between 1 and 23 that anyone wants me to take a look at? Yes, Carmen. 17. Okay. So we've got 17. What's the first thing we want to look at now? Greatest common factor. So what's the greatest common factor of 3, 36, and 108? If there is one, now, if there is a greatest common factor of 3, 36, and 108, it's only going to be 3. Because nothing bigger can divide into 3.
What about 3, 1?
Oh, we didn't even look at the variables. Is there a variable greatest common factor? Yeah, it's going to be y. So then 3y is going to become my GCF, and I want to divide each one of these pieces by 3y, which is going to leave me with what? 108 divided by 3 is 36 x squared. Now, can I find two numbers that multiply to 36 and add to negative 12? Because this is clearly not a difference of squares. So now I want to do this. I want two numbers that add to negative 12 and multiply to 36. Write everything out. You don't have to do things in your head. So if I look at 36, it's going to be things like 1 and 36, 3 and 12, 4 and 9, 6 and 6. And you know, yeah, you want them to add to a negative. So these are going to be negative pairs. And yes, it's obvious. It's going to be negative 6 and negative 6. So then your final answer is going to be 3y. The GCF comes down. Bracket, 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 bracket. What's it going to look like?
y
6x, good. Which if you look at the answer key, what is one way, how could we write this when we have the factors here that are the same? You could write it like this, y minus 6x squared. The answer key might have it written like this. This is the same as this. And you're done.
So it would still be correct if we wrote it.
Yeah. Carmen, does that make sense? Okay. Angel wanted 23. Is there anything before 23? We're rapidly running out of time here. Okay, here we go. 23. Angel, first thing we want to look at is what? GCF. So what might the GCF be if there's going to be a GCF? 7. Just 7? 7x squared y. Okay, so if I divide everything by 7x squared y, we're going to get, this is going to be y squared minus plus 49x squared. So now it's exactly the same as the previous one. It's going to be, y minus 7x, y minus 7x with my 7x squared y out front. Cool. 29 is the same. Oh, wait, hold on. Yeah, I will, one sec. Oh, haha, 29. Don't do 29. Do not do 29. Because once you take the greatest common factor out, the it's not a simple trinomial. You cannot do anything more to 29 other than take out the GCF. There are techniques I will teach you later. If you finished the odds, what I'd like you guys to try over the weekend, if you've got time, is to take a look at the next chunk, the evens. If you did not finish the odds, then just focus on finishing the odds. You'll get more time to practice this on Monday. I want to make sure you guys are comfortable before I give you the review. Have a great weekend. Unless you've got a question, then by all means, stick around for a sec. I'll see you next week. Hold on. Cheyenne. Oh. Cheyenne was supposed to come write me a test today.
I'm going to be here next Monday.
You are going to be here next Monday?
Yeah.
That's
but-
good.